Hello and welcome to this video. We're going to be talking about how Excel does its own mathematical calculation. It's very critical for us to know how all the calculation that we can do in order to avoid massive problems and maybe disaster results. So let's go ahead and put that in practice right away so we'll understand what we need to do. So I'm going to go ahead and zoom in a little bit for a larger screen. I'm going to click anywhere and hit Control Home to go to the first cell in the sheet, which is A1. If you notice in the calculation that I'm going to do right now, let's assume somebody has no clue how to use Excel. And I asked this individual to take three values, 5, 4, and a 3. And I asked them to find the average of these three values. Of course, there is a function in Excel, it's called average, that will help us and do the calculation in a second. However, this person decided to do that manually as we do it in real life. He needed to add those three values and divide it by the number of the items, which is a 3. So, of course, we all know that we start with Excel. You have to put the equal sign in order to start a calculation. So we're going to click on this, which is a good habit, to click on the cell instead of typing it yourself, so it reflects the value in the cell in case you change your mind. Plus whatever in D3 plus whatever in E3, and this is divided by 3. If I hit enter, not thinking about it or not knowing how Excel does its own mathematical calculation, we're going to get 10. Of course, 10 is the wrong answer. It's very problematic. If you think about it, like I'm giving a patient 10 grams or 10 milligrams of medication, instead of taking the exact value as a result of adding the three components together. So what happens, it's very simple, is the fact that before we do the calculation, we need to think first what we need to do and how Excel does its own calculation. First of all, Excel have in this specific formula, it has addition and division. The division is going to be higher priorities, higher precedence over the addition. So it's going to divide whatever in E3 by 3, which is going to give me 1. Then it's going to go from left to the right of the formula, and I take 5 plus 4 plus a 3, which is going to give me 10. So this is, of course, the wrong answer. How do we calculate the right answer? Is to say, okay, in order for me to find an average of anything, if I don't use the average function in Excel, then I have to add first, which is really emphasized by putting the parentheses around the addition first, which is going to raise the priority of the addition above the division. So now it's going to add the 5 plus 4 plus a 3. It's going to give me 12. Then it's going to divide it by 3, and it's going to give me 4. This is, I guess you have seen how problematic, again, if you don't think about how to supply or give that formula to Excel to do the right calculation. So in this case, if I have convinced you this is very important, let's go at every step from the very beginning to what we need to do or consider in order to get the right presentation or the right formula to Excel. We're going to divide this discussion into two sections. The first section is going to really trace how Excel does its own calculation. Then later we could actually take an actual formula from the real world, or actual equation is a better word in this case, and turn it into a formula or calculation in Excel without having an error in how to present it to Excel. Let's go ahead and do that. The first thing in how Excel does its own calculation. So this is first items. The very first thing that you must look into is the most inner parentheses. The highest priority is the most inner parentheses. I'm going to be using the draw here, which is I added to Excel. If you have a 3 set of parentheses, here we go. And the 3 set of parentheses, this is the most inner set. So this is where the calculation is going to start. Once we result with one single value between these two parentheses, we're going to have 2 set of parentheses. So we're going to move to the second level. Actually, let's call it second level. Then we're going to do all the calculation here until we get one more value. Then we have one more set of parentheses, which is level 3. And as a result, we're going to do that. And eventually, we're going to get, no matter how complicated the calculation is, going to give me one single value. So this is the highest order, which is the most inner parentheses, regardless of the mathematical operation that we will be looking into. The second thing, this is A. The second thing, which is going to be the exponent, which is the caret sign. Exponent, or the power operator, if you notice that the power is very powerful in that aspect, because it does a multiplication very quickly. When I ask my students what does actually exponent do, most of the time they answer it does multiplication very quickly. So instead of multiplying 2 by itself 10 times, I say 2 caret sign, which is shift 6 in the keyboard, raised to the power of 10. So this is basically what I'm going to go ahead and show you the result of that. I'm going to use that in one specific cell here, which is cell D10, 2 raised to the power of 10, and we're going to go ahead and see that it is 1024, which is the famous value for how many bytes in a kilobytes. And after we locate inside the inner parentheses the very first exponents, then we're going to be looking into another very powerful thing as well, is the either mod, if we do have the mod, which is a concept that I want you to be very familiar with, or integer operators. Actually, those are supplied in Excel not as an operator, are supplied as a function. And of course, it could be multiplication after that, which is the asterisk, and of course the division. Let's focus on these two first. Again, the parentheses, and where you put the parentheses will actually raise the operation ahead of other operation, or of course is going to lower it. But we know that if we don't have parentheses, exponent is higher than those if you ended up having them together. And we're going to go ahead and look at the mod, which very few people actually know what it is. So I'm going to go ahead and discuss it. Mod, it means the remainder. Okay? But before we talk about the mod in integer, we need to understand in the very simple form of presenting numerical value. Of course, in mathematics, we have a whole different discussion about it. We have 2 types of numbers. We have an integer number, which is a whole number, and also we have a real number, which is a number allowed to have a decimal point and a fraction of a value. So integer value does not allow anything to have any digit to the right of the decimal point. So if we have anything like 1099, it's going to eliminate those regardless of what they are. Don't round the value, just to truncate it, meaning remove it. The real value, of course, we're going to have a value that is basically, if I do 99 divided by 10, I'm going to be ended up with 9.9. So this is very critical for us to understand. This is, we'll keep the 0.9. So integer value is a whole value. I'm talking about integer first because I need to be able to talk about the mod, so I'll be able to understand how the mod is going to work. So the mod value is the remainder, and integer value is a whole number. They're related to each other. If I ended up taking the mod, which is the remainder, let me go ahead and show you how we're going to do it. If I say here, I have 10 kids, okay, and I have 10 kids, and I have, or let's say, actually, let's reverse that, 10 cookies and 3 kids. How many cookies each of these kids will have? Of course, 10 divided by 3 is 3, meaning every kids will have 3 cookies, but there will be something left over, or as a remainder, which is the mod, which is going to be 1. 1 is going to be whatever left out of the division. Whatever left out of the division. If I have, again, mod, let's say here 20, let's do any number, mod 3410. When I divide 34 by 10, I get full 3 tens, and the remainder would be 4. Okay, that's different from if I say to you integer, which is another function in Excel. 34 divided by 10. Now it's going to say, okay, how many tens completely inside of 34, which is a 3. So the division, integer division, is a 3, and the remainder is 4. It's very critical to understand those two. Mod is not really common, but it's very useful, as you will see. The more you know about computation, the more you're going to find it to be very, very powerful, especially when it comes to divisibility aspect, when we wanted to know whether a function, whether a value is divisible by another value. For example, if I say here I have 27 trucks and I have 9 employees, would I have any truck that is not being cleaned? Let's go ahead and see this. So I have 27 and I have comma 9. That's mean the 27 will be cleaned by 9 people. What is the how many trucks will be left without being cleaned? So it's going to be 0, because there is no that 27 is completely divisible by 9. But if I have 28 truck, if you notice here, and I have 9 people, if I wanted to give each of these employees exact number of trucks to clean, we're going to end up with 1 left without being cleaned. So again, you will notice so many different applications in the business science that will be very helpful to use the mod for it. So again, mod and integer are critical, but we wanted to go ahead and focus on multiplication as well. Multiplication is the asterisk. If I have 2 multiplied by 8, as you notice, it's going to give me 16. The same thing if I have 2 multiplied by 8, it's going to give me a fraction, because I did not apply the integer value. But if I did wanted to get a whole value as a result of the division, I will use the int function. Obviously, there is no way you could fit 8 in 2, and the result would be 0. And the other side, on the other hand, if I have integer 8 by 2, there are actually 4 2's in 8, and that's where we'll end up with the 4. So these are very critical values. One more thing I wanted to mention about the mod and the integer, which is a long discussion. I'm trying to do the best in this case, just to get the understanding going here for you. And with multiplication, which is very common, the division is very common. The mod, as a final thoughts about the mod, if you have a mod, a smaller number, mod, a larger number, is always the result going to be the smaller number. Imagine you have 3 cookies in 10 kids. Of course, where you cannot divide the cookies, because the cookies need to be as an integer value, as a whole value. No way you could really give a fraction of a cookie, and their way you cannot really give 3 cookies, and the 7s are going to be left without cookies. You would not really like to do that. So as a result, you're going to end up with a 3. Here we go. All right. So I'm sorry, we have to put the comma, not the division, and which is, I made a mistake here, which is good. We will see a lot of mistakes like those, and we're going to end up with the 3 cookies. Maybe you should eat them yourself. I know this is selfish, but you don't want to really give 3 cookies to 3 kids and the other don't have it. Go get more cookies. Anyway, this is basically one more thing about the multiplication and the addition. If you have multiplication and addition, you need to make sure that the calculation will always start from left to right. So 3 multiplied by 9 is, in this case, you're going to go 27 divided by 2. We're going to get 13 something, and here we go, 13.5. But if I use the same exact number but switch the calculation, 3 divided by 9, see here, multiplied by, let's say, 2, it's going to give me a different number because the calculation is going to start from left to right. And here we go. So we're going to get 0.66. So it's going to be really very critical for you to understand that the calculation always starts from left to right. So integer is probably a new thought to you. Mod, absolutely, and more likely it's going to be a completely new thought. But mod is the remainder. Integer is a function that we could use in the division. You don't have to use it with the division, but we usually use it with division in order to give us a whole number, not rounded number. That's a whole different function. You always have to actually remove everything to the right of the decimal points. Again, if you wanted to see an example very quickly, if I have 99 divided by 10, it's going to give me 9.9. And this is very tempting to see if I wanted to divide this as an integer to say it's going to be 10. No, it's not going to be 10. It's going to be 9 because anything to the right of the zero decimal point is going to be removed. All right, one more thing and we'll be done. And I'm going to go ahead, then I'll give you an example that hopefully will illustrate that and put it all in one action. I wanted to go ahead and do the last thing, which is, in this case, I had ABC. Let's go ahead and D here, which is the final thing, which is addition and subtraction. Exactly like the multiplication and the division, you always start from left to right. So if I have something like this, if I have something like a 3 plus 3 minus, let's say 3, that is going to give me, let's say minus 4. 3 plus 3 is 6 minus 4, because we start from left to right, it's going to give me 2. And if I do the same thing here, but I switch the operator, I say 3 minus a 3 first, then a plus 4, of course it's going to change the result, because 3 minus 3 is 0. It starts from left to right, plus 4 is going to give me 4. So this is that theory behind how Excel is going to do the calculation and the concept, and we understand that the highest thing is to look at the most inner parentheses. Then once you locate that most inner parentheses, you look for the exponents. Then you really decide whether you're going to go from left to right, see if there's any mod, operators, integer, multiplication, division. You could do those from left to right, again depending on how the formula is being written down. Once you remove the multiplication and the division completely from right to left, you're going to do the addition and the subtraction. I had to interject the mod and the integer because we cannot live without the fact that we have an integer value that we really need to present, especially in the physical entities where you have a person. You don't want to have a decimal value associated with number of people or number of trucks or TVs or tables. All these must come or presented as a whole value. The mod is very helpful with the divisibility aspect of calculation, and it's very powerful operator. You will see more use for it when you get more advanced in the use of Excel. Okay, let's go ahead and get a full example of what we have learned so far. It went all over the places. Now we have to make it more concrete for us. Let's assume that I gave you this problem. And one thing I wanted to give you ahead, if I didn't mention it in another video, if you go to a cell and you say equal, which is indicating to Excel that you're about to do a calculation. If I say 9 plus 3, that's going to give me 12 because Excel acting immediately on it as a calculation. But for illustration purposes, if I wanted to leave this calculation so I could know what I'm doing, if I started the cell by a single quote, Excel will treat the whole thing as a comment, as a remark, and will leave the calculation alone. So this is basically what I'm trying to show you if I do insert the single quote at the beginning of a calculation, so I could illustrate to you what I'm doing instead of showing you the result. Of course, there is another way in Excel to present everything in a formula view, but that's a whole different story. So let's go ahead and get this example together. Let's assume for whatever reason I have this example and I have one parenthesis, and then I say here another parenthesis, and maybe let's go ahead and make it a little bit challenging. So we're going to go ahead and say here, no, 3 raised to the power of 2 plus 3, and then I'm going to say plus and open another parenthesis. I'm going to say 3 raised to, actually multiplied by 2 raised to the power of 2, making it smaller, plus mod, say here 14, comma, let's say here 6, and plus 2 multiplied by 3. So let's go ahead and start with something a little bit challenging, but it could be a lot bigger and much more challenging if we wish to do that. So how are we going to actually going to think through the process of how Excel evaluated this? The more you get intimate with Excel and get to see how it does its own calculation, the more you're going to be fluent with it, you know. So in this case, I'm going to go ahead and hit enter to show you the result, which we obtained 32. But now I'm going to walk you through all this so you'll be able to see how Excel is going to do that. So I'm going to start with the single quote, and this single quote is going to prevent Excel from showing the results. It's going to leave the actual calculation alone, as I wrote it as a comment. Now we're going to go ahead and look at the second, at the most inner parentheses. First of all, the mod and the integer, they are treated as a function in Excel, and as you have seen, or if you haven't seen in a previous video, that all function in Excel must have their own parentheses. So when we do count the number of the nested parentheses, meaning how many set of parentheses I have, do not worry about the parentheses that comes with mod or integer, because mod and integer, even though they are mathematical operator, but they are presented as functions, so they must have their own parentheses. So in this case, we have only 2 set of parentheses, and we need to know where is the most inner one. The 2 set of parentheses, I'm going to change this to red. Maybe that will actually make it better. You could go ahead and do that if you would like to. So I have this set of parentheses, which is the first level. Do not count those because they belong to the mod. And then I have another set of parentheses right here. So where do I start my calculation? I started here. This is how Excel is going to do. That calculation is starting here. So I'm going to go ahead and see how we're going to do this. We're going to go ahead and put the single quote to leave it from being calculated. It's going to be 3. I'm not going to see even those because they have to be left until I deal with everything inside the most inner parentheses. Now, I'm getting inside the second inner parenthesis. I have multiplication and exponent. Which one comes first? Of course, as we have seen before, exponent is higher than multiplication. So it's going to be 3. Leave the multiplication alone. Act on the exponent. What is 2 raised to the second power, which is 4? That's how you should do it. And of course, those we're not touching until we actually finish the most inner parentheses as a single value. And you will see it's going to be done in a second. And as you notice, I'm just typing this. And look, take a look. Oh, of course, make a mistake here. If I make a mistake, it's going to carry itself with me in the next line. See here, I wrote mod as a lowercase. No big deal because Microsoft is not a case sensitive. And in this case, we have to go ahead and look at the most inner parentheses which is in this case 3 raised to the second power plus a 3. Let me see here if I did that correctly. Yes, and now what we have to do, inside the most inner parentheses, I have only one single operation left, which is a 3 raised to the multiplied by 4, not raised to, it's just going to be 12. That will actually allow me to eliminate the inner parentheses completely. So I'm left with this 14, 6, and plus 3 multiplied by 2 multiplied by 3, sorry. And here we go. Still we have to continue. Now we don't have any most inner parentheses. We have one large set of parentheses at the beginning and the end. Again, don't count the mod. We're going to start from left to right. So the very first thing I have to do is to look at what is the highest operator inside a set of parentheses, which is the exponent, which is a 3 raised to the third power in this case, which is I moved it incorrectly. Actually, this is supposed to be 3 raised to the power of 2. So if I do not see this mistake, it will actually give me the wrong result. So 3 raised to the second power, which is 9, plus a 3, plus a 12, plus mod 14, 6. Okay, plus 2 multiplied by 3. And that will actually save me from one step. I know it's a lengthy process, but we need to understand that. So we have to have 9, and next time I don't do the addition. Look, the mod is in my way. I'll take care of it. So I'm going to say 9 plus a 3 plus a 12 plus the mod, which is what is the remainder. When I do divide the 14 by 6, there are fully 2 6s in the 14, so the remainder is going to be 2. And of course the multiplication, which is 2 multiplied by 3, I could do that as well at this moment if you want to. That's going to give me the 6. Now everything is based on addition. So we're going to go ahead, I mean, if you want to really go inside Excel how it does it, it's going to add the 9 to 3. It's going to give me 12 plus a 12 plus 2 plus 6. And next time it's going to give me a 24. Sorry, here we go. 24, and then plus 2. I wanted to see the whole process. Plus 6, and this is going to give me a 20. Let's say here 24 plus 2 is 26. 24 plus is 26 plus 6. Here we go, and the final result, which is now I could remove everything, which is going to be 34. And let's see if that is the case one more time. If I take that out now and asking it for a calculation, and it's going to be hopefully 32. So there is a mistake here. And where did we do the mistake? Let's go back and look into it. So we have here, it's okay. That's why we could really learn from our mistakes. Where did we make the mistake? That result was 32, and we ended up with 34. If you notice here, it's 26 plus 6. That is actually 32, not 34. So my mind, as a human, actually deceived me, because now I'm looking at 26 plus 6, 26 plus 6, here we go, it's going to be 32. So this is a good example of why we should really learn these, and because we as a human possibly make an error, and once we understand the rule of mathematical calculation in Excel, we should be able to really have no problem whatsoever. So my mistake was mentally, with the speed of my talk here, I ended up adding the 26 plus 6 as 34. This is how my mind saw it, but it is 32, and luckily this matched this, which is 32. I'm going to go ahead and put that just in case you wanted to practice, and here we go. I want you to also continue to practice with this. You could take any problem of your at any level you want. So I'm going to go ahead and create a couple problems for you to really practice with those and try to see if you're going to get the result, but take it step by step. So let's go ahead and do this. 3 parentheses, 2 raised to the power 4 plus mod 3 divided by 10. A smaller number mod a larger number is always the smaller number. Then we're going to go ahead and add another set of parentheses. Let's say here 4 multiplied by 2 minus 10 plus 20. Here we go. We're going to get another set of parentheses here. Plus 3. Okay, let's close that. Then we're going to here say plus 3 and close that as well. That's going to be the red color now. You notice that the color of the parentheses would match. You know, when you match the red by the red, that's mean you close the red parentheses. Then we're going to say here integer, which we haven't really played with, 44 divided by 10 and plus 2. I would like you to play with this one step at a time and see if you're going to get the 54. Here we go. Let me go ahead and pause it here for a second. So when you watch the videos, you will be able to take your time and practice with it on a piece of paper. Okay? We still have something very important to do in this video, which is really probably the most important part. Everything is important when it comes to learning, but the second one where we deal with it from our own perspective. So if I go ahead and show you here, let's assume that I have this formula. I'm going to give you, first of all, a smaller formula that is given to me by a mathematician by saying, look, the volume of a cone is equal to 1/3 of pi, which is a Greek letter to indicate the value of 3.14. Of course, the 0.14 to the right of the decimal point could go infinitely, but this is to quickly introduce you to pi, multiplied by the height of the cone and multiplied by the radius of the cone raised to the second power. This is what is the mathematical or equation for calculating the volume of cone. Of course, you have zillion and zillion of these formula that found over the years, giving to us free without the efforts of really reinventing the wheel, but we can really turn that into an actual calculation in Excel in no time. Then I said to the scientist, okay, what do you want me to do with this? He said, can you find me the volume of a cone that has the height of 5, okay, all right, and the radius of 6.4. No problem. We could do that very easily. This is, I'm going to label this with the full word, meaningful word, height, and this is 6.4 is going to be the radius. Now, in this case, I really need to know how to convert an equation into a formula. Formula is what we write in the cell of Excel that will convert something mathematically like this, or scientifically, or business equation, they're all over the places, into something Excel can relate to, okay? Excel can act on it. So I'm going to go ahead and say this is the volume here with a good label. Then we're going to start with equal sign. And how are we going to convert it? We're going to actually 1/3 is a constant. So we're going to go ahead and divide 1 by 3, put it between two parentheses. In this example, it doesn't make a difference, but it's good to get into the habit of using more parentheses in order to clarify your calculation. So what is the 1/3 is doing to the pi, which is next to it? It's multiplied by it. So multiplication is an asterisk. And what is pi? We have many ways of putting the value. If you wanted more accuracy, more precision, where the volume of the cone is going to be hugely important, then you could go as far as like 10 digits to the right of the decimal points. You could actually stick with 3.14 for now. Not only this, there is a function inside Excel, it's called pi, that actually give you a more accurate value than 3.14. But to focus on how to change this function into formula, that's what matters the most in this example. So this is multiplied by what? Actually multiplied by the height, asterisk, multiplied by whatever the value of the height, which is in this case happens to be 5, could it change to any value, and that is multiplied by the radius, and the radius is raised to the second power. So whatever in the cell E45, exponent raised to the second power, which is 2 squared. And now if I hit enter, of course you're going to get the volume. So this is a very easy example. Let's go ahead and make it really a little bit more challenging. Let's assume that I have another example here where we're going to really be a lot more involved in that. So if I have something, let's say somebody gave me, I'm going to make up an equation that is really complicated like this. Say I have here x multiplied by y multiplied by z raised to the 7th power, and the whole thing is divided by x squared, let's say 3 multiplied by x squared multiplied by let's say z, okay, this is x squared. There we go. So I'm going to put that notation accordingly, okay? And we're going to go ahead and do that. And I'm going to put z, and let's say here, again, another, that's the division here. Another, let's say q. All right? And the value of this is going to be basically, let's say something called v. All right? Or, okay, we're going to choose v or m, whatever. And I said to the scientist, what the heck do you want me to do with this? He said, go ahead and create an actual formula in Excel for me. So when I put the value for x and y and z, also q, I'll be able to find the result of what v is going to be. I said, no problem. It's very easy to do in Excel. So I'm going to go ahead and first of all put x here, the value of x, that's a label. And this is y, this is z, and this is a q, and this is where is v, which is the result. I'm going to put it a little bit far from the others. So if he said, okay, start with any value you want, I'm going to put all of them 1. Here we go, 1, 1. Okay, so okay, it doesn't matter. But this is what matters, is how to convert this into an actual formula in Excel. Let's take a look first at the actual function that I was given. Regardless of what this function is going to do for me, I mean, I could go to Google and find hundreds of meaningful functions, but it doesn't matter because we really need to be able to convert any function, no matter how ugly it is, into an actual formula. First of all, let's notice that this whole thing is divided by this whole thing. So we have to start with this open parenthesis here, and notice that the z is raised to 1 over 7. And of course, x raised to the 2nd power as well. So all this must be taken into consideration when we're trying to look. I'm going to make a mistake on purpose, and I want you to really pause with me about the type of mistake that I'm going to do it in order for you to never ever do it in the real world. So what are we going to do in order to do this? I'm going to start open parentheses. Where is the x? It's in this cell. Multiplied asterisk by y, which is in this cell, regardless of what the cell address. Multiplied by z, raised to the 7th power, 1 over 7. Close the parentheses. The whole thing is divided, open another parentheses, a 3, which is a constant, multiplied by x, which is this one, regardless of what is the value, raised to the 2nd power, and that is multiplied by z, here is z, and that is multiplied by q, which is here. Close the parentheses. That's exactly what I want, except for the mistake that I have done, or I did on purpose. So if I hit enter, that gives me this value. Okay. pause with me for a second and try to think, where is the mistake that I have done? All right. If you recall, when we discussed the rule of orders on the top, the highest when it comes to mathematical operator is the exponent. In this case, I have exponents and I have a division. So now I have to think, whatever in the value of E53, which is Z value, this value is raised to 1 over 7 as the exponent value is 1 over 7. But because exponent is higher than the division, what Excel will do, it will take the value of E53, raise it to the power, and whatever the result from that calculation will be divided by 7. But that's not what I want. I want the whole thing to be raised to the power of 1 over 7. So therefore, if I don't emphasize this by putting the parentheses around this fraction value, we're going to get into, again, another problem similar to the one that we started this video with. So please make sure to actually, you notice the value has a change. I'm going to make it here to illustrate this more clearly. If I have 2 raised to the power of 1 over, let's say, 7. That's going to take the 2 raised to the power of 1 first. Then the result is going to be divided by 7, which is going to give me 2.85. However, if my intention was to raise the 2 to the power of 1 divided by 7, which is the exponent is 1 over 7, or the 2 to the power of 1 over 7 as a whole, then notice it's going to give me a whole different result. Of course, if this is changed to 300, and this is a change to 300, it's going to make a huge difference depending on the calculation. See, so we need to be able to make sure that when we present our functions that we will turn into formulas for Excel to do the calculation, we need to present them again accordingly. And always think about parentheses. Some people say you use too many parentheses. I said it's better to use more parentheses for clarity than less parentheses. And if I go back to, just for the sake of completing my discussion, instead of using the 3.14, I could use a function here. It's called pi. Remember, pi doesn't get anything between the parentheses, and Excel will actually print that value, which is more accurate value. See, I got here 214.66. If I just use 3.14, it's going to be less accurate. But that's basically, we could use some of these functions even in the calculation if you wish to do so. See that the function pi is going to get the value from Excel, then it's going to really use that value again according to the rule of order from left to the right. I know this is a little bit different from any other videos you're going to see, but this is really important for us to understand the nature of the beast. And if we understand how Excel does its own calculation, then there's nothing for us to fear. Again, this is Dr. Sam Hijazi. I really would like to welcome you again to my videos, and I hope to see you in the next one. Thank you so much. See you later.